Treehouse, I need to make clear, Semantic Treehouse is an open source platform developed by TNO. And a vocabulary hub is an architectural component of a data space. And so the headline here is Semantic Treehouse is just an implementation of a vocabulary hub. So it serves as a vocabulary hub here. There might be others. In fact, there are. But for this project, for HEDGE-IoT, we have Semantic Treehouse as a vocabulary hub. And as this picture shows, it plays a role in this transversal use case. It plays a role in connecting data and sharing data between a data source and a data sink, or you could call it a data provider and a data consumer. And I would like to make that clear. But first, a deeper dive in those scenarios. So we're talking about a data provider, scenario 1, makes a data set or service available within the data space. And I would like to focus on one of the steps for that mentioned, namely defines the associated metadata. That's what the catalog, but also the vocabulary hub is about. The catalog is very generic metadata, and the vocabulary hub is more about the structure, the meaning of the data itself. So these two will work together, the catalog and the vocabulary hub. And the purpose, of course, of all this is to make the asset more discoverable, which is scenario 2, which I will get to in a moment. But here is a more elaborate outline of the steps of this use case, the use of data space by a data provider. And you can see 6 steps. 1, new data available, so that's the starting point. The data provider is supposed to decide select some data set or service to make available in the data space, and it ends at 6. Called idle, which is awaiting request from consumer. So now you have set up shop, and it's time for so to speak, waiting for the customers to arrive. But we are talking about not all the steps, but about step 2, which is defining the metadata, and even not all metadata. Some metadata is in the catalog, like I said. And you will be able to do on your own as a data provider. These are basic things like who are we, or what is the data about, in the sense of what can we give like a title for this data set. Some stuff in the catalog is not basic. For example, usage policies. This is out of scope of this presentation, and it's out of scope of task 4.3 in the first place, as we are a task focused on semantics and interoperability. So, as I'm saying, we are here to, with the vocabulary hub, to provide assistance in step 2, which we facilitate by the vocabulary hub service provided by us. And the purpose of this definition of metadata is to get it captured by the IDC connector, also marked with the orange line, and the catalog at the end. So there's an interdependence here, but we won't go into detail about how these two components work. This is for another time. So data providence, and then data consumer, scenario 2. Findability of the data is managed by the catalog. Thanks to the metadata, the consumer can evaluate if there's a usefulness. That can be done based on usage policies, right? Are they too strict, or is there something possible? But it can also be done based on what the actual data is about. What is this thing about? That's what the vocabulary hub is here to help with. So the data consumer starts here with a need, and if all goes well, we'll have plenty of metadata to decide on and see if there is a match between the supply and demand. Okay, so that's the basic context. So so what are we going to do? Well, this is some theoretical background. I won't go into much detail here, but this is a very common framework. I think many of you will know it. And semantic interoperability is just one of the few layers. So the catalog and other data space components like the connector is a lot about has to do with the technical interoperability. And by adding the vocabulary hub in the mix, the data space frameworks achieves the semantic interoperability layer. Data space connectors work with the data space protocol. This is recently standardized, as many of you know. And this is where the catalog is mentioned as well. And what's nice about the data space protocol is that it uses open standards. So for the catalog, for instance, it uses a standard called DCAT. I think we have discussed it before. For example, not in this slide, but for contact negotiation or identity management, other standards are used. For example, users policies in contract negotiation are done mostly with ODRL. But I digress. This is mostly about DCAT. The catalog is defined in DCAT. So what is DCAT? It's just an RDF vocabulary designed to facilitate interoperability between catalogs. And so a catalog looks something like this. This is the JSON linked LD serialization. It's a little small text. To the right, you can see a class diagram with DCAT to the top and DCAT catalog on the top and DCAT dataset right below, because catalogs consist of one or more data sets, right, in their catalog. This can be services as well, by the way, as you can see in the top, in the bottom right. So you can see if you zoom in a little bit, I can't, but if you look closer, you see some standard things like a title for the catalog, a description, maybe an owner or participant, and an array, a list of data sets. So if you expand this, then the interesting, the wheres, so to speak, are included. So this part of is a DCAT data set. It's a standard way of describing a dataset entry in a catalog. So you see a title again, description, and also a distribution where you can find the actual data with an access service. Now, this is one of the key points here, is that we use the DCAT language to link to the vocabulary hub, to link to the more semantic metadata in the vocabulary hub of this dataset. And luckily, the DCAT catalog has a property, a standard vocabulary property here called DCAT conforms to, which you can add with a specific link to the metadata about this dataset stored in the vocabulary. And this is what we do. This is how we can do steps, the steps we showed before, like these here. When I go back, the user provides metadata, uses the vocabulary for that, and then adding that link to the catalog is how we achieve this step define metadata. Okay. So then if you follow that link, you see a human readable view as well. Again, a little small perhaps, but this is the Semantic Treehouse, like I said, our implementation of the vocabulary that we use in this project. And now you see, we are in the data model for energy or cumulative measurements. And there is all kinds of information like what this data model looks like, what this particular property is about, and even if a definition, or even if there are issues within the project, questions about this part, which is a separate issue tracker that's in the vocabulary here. So this all goes to show that the catalog and the vocabulary can be linked through the catalog conforms to property. And so I would like to start the demonstration now, where we can have a closer look to at some of these examples that we prepared. So I will stop sharing this part. There we are. If we go to the energy.vocabularyhub.eu URL, which I will, for your convenience, share the link in the chat as well. We we arrive in the NG vocabulary hub used by multiple projects, not just HEDGE-IoT, but including HEDGE-IoT. And we can go to some specifications. Note that I am authenticated. We don't create separate accounts for you here necessarily. You can use any some multiple ID providers like GitHub or LinkedIn or Microsoft to authenticate. But since we have some issue tracking here, we would like users to authenticate, but you don't have to. In some cases, specifications stored in here, metadata about datasets, can be hidden for non-authenticated users. So if you can't find or follow along, even if you're watching this recording, if you can't follow along, it might be the case that you need to log in or authenticate. If you still can't find the things that I am doing here, then you might need some more authentication, and you can just contact me or my colleagues at TNO. For now, I would like to continue the demonstration. I have a hidden group here, HEDGE-IoT unpublished. And like last time, we requested some data examples from the pilot to show our meaning here. And there are some data models here for meters, data model for cumulative measurements, data model for interval measurements. These are all based on SAREF, so standard vocabulary. But we also have a message here that we made from our data example. I think we received this from our Greek partners. Correct, Roderick? I think so. And
yes, the last one.
Yeah. So we simply loaded, hit the plus sign here, added message model. This can be data model. These are synonyms for our purposes. We gave it a name and we said, well, we have some sample data, which was JSON, if I'm not mistaken. We just pasted it in here. This button lighted up, and we clicked, and we had this. What it does in the behind the scenes then is the semantic treehouse generalizes a data model based on this particular data example. So what do I mean with generalizes? Well, let's have a look. It generalized this data model from a particular data example, meaning that it found a timestamp, and from its value, which it took as an example value, it inferred, this is a date time. It does some tricks like that. Also, it generalizes in a sense, it guesses the cardinality, which means, in general, do we expect current or voltage to be a mandatory inclusion of this data or optional? In the latter case, you would expect not a 1-to-1, but a 0-to-1 cardinality constraint. This is the place where, taking the Greek pilot as an example, and in particular this data offering, this is the place where more metadata. So we started with the metadata, right? We can link this specification in the catalog through the DCAT conforms to property. So already we now have in this catalog a link to more metadata. This is what the data is structured. These are the fields. But it doesn't need to stop there. It can go a bit further, like example values, like typing, definitions. In fact, we can go to edit message and maybe add a few usage notes here, saying anything that you can add about this particular field, maybe the way it was measured, maybe anything else that you would like to make a prospective data consumer to be aware of. This is the fair data principle of writing as much about your data for a still unknown end user for an unknown purpose. So there's different interoperability levels that you can achieve here. What's more is that the vocabulary is not just a, in particular this implementation, Semantic Treehouse, is not just a static repository of these data models. It's also a place where convergence can happen between those models. Of course, this is important because if you have a data model in the catalog, you make some more information about what your data set is about, but we are trying to foster interoperability here. And interoperability doesn't just happen with some nice metadata. Interoperability happens when there is a convergence of the way data is structured between data sets. And so one of the ways this platform facilitates that process of convergence is by allowing others, to view this and to create an issue or a review comment, maybe asking, maybe doing suggestions. Another way, by the way, if these issues are made, it arrives in an issue list, and as a group, for example, as a pilot group or a task 4.3 here, we can work these out and work towards a more common way of defining data sets, and we plan to do that exactly. But another way of facilitating convergence is by allowing comparison to other data models. Say, not only the Greek, but also the Dutch pilot have provided their metadata about their data sets here. We could say, well, let's compare. I have here the wrong one, so let me add another one. Let me search for measurements. And I know that this one is, so we can expand. So now we start, we see that there's an issue here. It's quite small, so I'll zoom in a little bit. That's much better. So we see already that there has been made an issue here, a question of some kind. A problem with this property. This one has been made with interoperability by design. So that means that this data model is derived directly from the Saraf language. This is another functionality of the vocabulary, but this is out of scope of today's demonstration. But basically, you need not to start with a data example to create your metadata. You can also start by picking a class of the Saraf vocabulary and work your way through the ontology there for your use case. We can start comparing these data models so that when we select one, the mapped field of the other, the related field of the other will highlight. And in later iterations of this platform, we will be able to see more information about the exact nature of the mapping. But this is another example I would like to show you, that when we get, not just the Greek example or the Portuguese or the Dutch example in here, but more work is being done on this transversal use case number 1, then we can start to get an overview here on these descriptions, and we can start to do the work of, well, let's see how they relate. So I think for now that concludes the demonstration. All kinds of different starting points, right? No pilot is the same. In fact, within the pilot, there might be all kinds of different data services. So we don't know the preconditions. So that's why we have created some flexibility in this platform, because whatever the precondition, I think if you want to do data sharing through the data space, you need some way of cataloging the data that's offering on your end. And any cataloging is improved with more information on your semantics. So if you already have a lot, that helps. If you have a JSON schema or maybe documentation, human readable documentation, that already helps. So what we showed you here was a scenario where which we think is common, where there's a relatively undocumented the API or data set available. Maybe even some a little small data set like measurements. I should say focused, probably a focused data set. And then you can start. If you have a lot more already, maybe even an RDF vocabulary, then that too is very good, and that you can work with that. You can take that along with you when you work with the vocabulary for the purposes we just described. These are all different starting points, and I can show you, in fact, what that would look like very briefly. To illustrate, so we are here again, and say we are the Dutch pilot. We want to, oh, my screen's clipping. I don't know if you have that as well. Yes, yeah, there it is. Okay, so say you are ready to add a model of your data by means, right? So that's the way we are adding metadata here for your data sets. So here's a model. And this is the place, for example, in our Hedge, we have the Dutch HEDGE-IoT dataset example. I don't know, I'm just making stuff up for demonstration purposes at this point. And now this is where we can say, well, what is your starting point? If you have sample data, then please use that, because then we can generalize the data structure from that. And you can work from there, make some additions, right? Maybe some generation went wrong, like maybe this field is not mandatory, it's optional. But that's much easier than starting from scratch. But like you said, if you have a pre-existing model in JSON schema format, for example, you can put that in here too, or link to that. Or if you even have an RDF vocabulary or multiple RDF vocabularies, you can add them here as well. And it allows you to pick a root class from those set of ontologies, and you can create your model of your application or your data set from there. Before I show you